Hey guys, it's Chili here. Welcome to STD Gems. This is a new series that I'm doing here. It's going to be some bite-sized videos where I introduce some cool and useful stuff from the standard library in every episode. So today, and for the time being, we're going to be looking mostly at the algorithm library. And there's a lot of stuff in the algorithm library, obviously, but we're going to break it down step by step, little bite-sized chunks. We're going to cover a bunch of related stuff today. We're going to cover the CopyIsh stuff. So these guys here, that's the topic for today. STD copy, you might have seen me use it in videos. It's pretty goddamn simple. You give it a couple of input iterators defining a range like this, and you give it an output iterator defining the start of the destination, and it will copy from that range into the destination. It's pretty simple. Let's take a look at the code in action. We've got a couple of containers here. I'm going to write those containers out just to show you what they contain. I'm going to run the copy, and then I'm going to write out again. This function here, write to cout, is a template function, and I'll talk a little bit about it later on. But right now, all you need to know is it just fires out the container contents to the console window. And if we run this, you can see here we've got our containers here. They contain strings that are words and digit representations of numbers, and we're copying from the first one into the second one, and here is what we get. So it is fairly straightforward here. We give it the range to copy from, we give it the place to copy to, and it will overwrite what is in those places from the source range. Now, one interesting thing about copy is the source and the destination, they can actually be in the same container. There's only one restriction, and that is that your destination, it can't fall within the range of your source range. So it has to be outside that range. But as long as it's outside that range, copy is going to work fine in the same container. So here you can see my source range is at the beginning of B. My destination start point is just a little past the middle of B. And if we run this, we can see that, yeah, we're copying the beginning of B into here. So we're duplicating that part of it inside the same container. And that's fine. If you put the destination inside this range, you're going to get a little bit of a weird result. So here we see that we're duplicating it, but we actually we triplicate the 0. And that's because we're writing into the source while we're also reading from the source, so that 0 actually gets copied twice. There's a way around that. I'll talk about that in a little bit. So you can copy, overwrite the contents of a container or whatever. You can also use iterator adapters to do things like insert. Using copy, you can insert into a container, but I don't really do that much because containers like STD vector, they have an insert operation that takes iterators and it does the same thing. So there's really no point to bring STD copy into the equation there. So let's say you want to insert or append a bunch of values to cout. Well, you don't have an insert method. You can't really do it that way. But what you can do is you can use this iterator adapter to create an iterator from this stream. And then you can use STD copy to copy from your container into that stream iterator. And that's what this function here does. It takes a container, and it also takes an optional delimiter here, and it will copy the whole contents of the container into cout, and it will use the delimiter that you give it as separators between the values that it copies in. So that's what we're using here, and it's a neat little thing you can do with STD copy. One thing you might notice here is that the OStream iterator, it requires the type of the value that is going to be inserted into the stream. And with a container, this template, we're only templating on container type like vector. We're not directly templating on the type of vector. So you can use these little helper type defs that are defined in your containers to get the value type and use that. These little things you can use to make your template functions and template classes. You know, I'm talking about these guys here. You can find them in the documentation for your containers at this point here. Now, C++11 gave us a little boy called CopyIn, and this one is a lot like copy, except instead of taking an input range, it takes just an input iterator and then a number of elements to copy. So that can make your life maybe a little easier instead of having to, do this little iterator arithmetic bullshit. You can just say, well, you know what, just give me 4 dudes starting from here and put that out there. and we just go CopyIn. Let's change the range to be something that is valid. Yeah, we get the expected result. So it's a little bit of shorthand, saves you a little bit of typing, maybe makes it a little clearer. Now, CopyIn can also enable you to do things that wouldn't otherwise be possible. Let's say I want to copy 5 values from CIN, std CIN, into a container. How would I do that? Well, I need an input range, right? The first one is easy. That's just your input adapter. But what is the second? What is the end part of the range? Would it be, input plus 5? No, you can't do that because the type of iterator that you get from this adapter doesn't support this operation. It's not a random access iterator. So how do you get the end iterator? Well, you can't. But what you can do is you can go CopyIn, give me n things from this input stream, give me 5, and jam them into B. And if you run that, now we can get 5 things. So let's put 5 things onto the stream, press enter, and there you go, jam them into our container. And you can do that. I mean, it's not super useful for console input, but it could be very useful for things like file input. Now, copy backward does the same thing as copy, but it does it in reverse order, which is sometimes important. Let me show you what I mean by reverse order. So with copy, normally you're going to copy, it's going to copy this one here, it's going to copy this one here, so on and so forth. But with reverse copy, it copies this one here first, then this one, then this one. The end result in this case would be the same either way. The order is just reversed. Now, sometimes it does make a difference. So let's look at the case again where your destination start is within the range of your source. So you copy this one, it overwrites here. Then you copy this one, you get a B. Now you're copying this one, you get the overwrited A again. So you triplicate A. Now let's try this in reverse order. So in reverse order, we're going to copy C. So C is going to go here, then B goes here, then A goes here. Look at this. Now you don't get the triplicate A if you copy in reverse order. So if you have overlapping source and destinations, it pays to copy in reverse order. If your destination start is within this range. If your destination start was here, you would want to use a normal copy. To me, copy backwards isn't that interesting because it's basically redundant. You could achieve the same effect by using rbegin and rend to get reverse iterators and then using normal copy with reverse iterators. In fact, you can see copy backward probably does that because it requires bidirectional iterators, so it has to reverse them either way. Now we come to CopyIf. CopyIf is probably the most versatile in this whole set here. It can be used for filtering, which is something that you do all the goddamn time. So how does it work? Well, you give it an input range and an output start point, but you also give it a predicate. And what it does is it checks every value against this predicate, and it only copies if it passes. If it fails, it skips it. And this can be great for filtering. So let's say I got a couple of strings here, and I want to get only the capital letters. I want to filter them out, and I want to get them all into a single container, into a single string. So what I can use is I can use CopyIf as a filter here, and copy from these strings using back inserter, append them to the end of my destination string. And my predicate is going to be std is upper, which just checks to see if a character is an uppercase character. And that can be found from CC type. So if I run this, here's my 2 input strings, and here is all of the capital letters collected here, filtered out from these 2 strings. Pretty simple, pretty clean, pretty sexy. Now, let's say I want to copy some strings from A to B, but A is going to be destroyed anyways. So, I mean, what happens when we copy these values? When we copy a string from here to here, it's going to create a new string as a copy. It's going to do a memory allocation, and then it's going to put that in this place in the vector. It's going to replace this one. But if this A is going to be destroyed anyways, all these strings are going to be destroyed, we don't really need to do a new allocation. We could just use these strings, move them into here, and we could save ourselves some effort. How do we do that? Well, algorithms provides us with move and move backwards, which do the same thing as copy and copy backward, only instead of making a copy, they just move the content. So we do std move from A to B, and I'm going to write out A and B afterwards to see what happens to both of them, and a little custom delimiter on A to make it easier to see what's happening here. So we run that, we see after we do the move, 0, 1, 2 has been replaced here just like a normal copy. But what happens to A is 0, 1, 2 actually get pilfered. So those strings become empty because, I mean, their content is no longer there. It's been moved into B. So that's the difference, and it can make things a lot more efficient, or in some cases, it can make things possible that weren't possible before, because as you know, there are many data types, like for example, unique pointer, that cannot be copied, but that can be moved. Now you might be wondering, okay, well, where is MoveIf, or where is, MoveIn? And they don't exist. So what happens if you want to, do a filter, but you want to move instead of just copying? Well, you can do that. You just got to be a little clever about it. So let's say we want to move from A to B, but we want to filter and only move those strings that have a length greater than 3. So how do we do that? Well, we start with CopyIf because that's what we need in order to do filtering, but that will do a copy, not a move. So what we got to do in here, std make underscore move iterator. So we take our normal iterators, we turn them into move iterators. We got to do that for both iterators in the range because we're going to be, iterators got to match up. And so we're going to be moving from this range, and the destination is fine, doesn't have to be a move iterator. So we just go b.begin. Actually, what I want to do here is I want to go a.end because I want to go over the whole thing. And now it's still angry because it needs a mother trucking predicate, right? So the predicate is going to be, so we take in a std string, we'll take that in by reference, we'll call it stir, make it const because that is my fetish, and we just want to return stir dot size greater than 3. And there you go. That should be everything that we need. Let's save, let's build, see if we get any errors. We don't get any errors. Here you can see we have performed the filtering. All that remains in A now are the guys that have a length of 3, and these ones have been overwritten in the destination. Now what you might notice here, and what might be, you might have been expecting that, for example, here would be 0, and then there would be, digit 1, digit 2, and then we'd have the word 3. But that's not how it works, because when you skip over something in the source, it doesn't advance the destination. The destination stays the same. So you're going to have all these guys in line. That's one thing to make note of about how CopyIf works. Although personally, when I do CopyIf, I'm usually appending to the end with a back inserter instead of overwriting stuff. But there you have it. And so here we see that actually move and move backwards are both also kind of redundant because we can get that same functionality and more by using iterator adapters. But they're there if you want them. Another thing you might notice here is after you move out of A, it's got a bunch of these empty husks just left in it, stinking up the joint. And that's fine if you're just going to destroy A anyways. All right, let me give you a real-life example of how you can use CopyIf. So I got a vector of poos, and what I want to do is I want to select one poo at random from that container and use it for something. But I only want to select poos that are stationary. So what I do is I create another container, and it is of reference wrapper to poo. And then I CopyIf from my container of poos into the reference wrapper. And what this is going to do is when I copy from here, it's not going to create a new poo in here. It's going to create basically a pointer to a poo. And I'm only copying the poos that are stationary. So at the end of this here, I'm going to have a vector of pointers to stationary poos. And then over that range, I can just randomly select an index and use that pointer to do something with that poo. And that's it for today. That's it for the copy boys. Hope you enjoyed it. Hope you get some use out of them, especially this filtering stuff. I find it very useful. I use it all the time. Hope you enjoyed the video. If you did, please click the like button. It helps a lot. And I will see you soon with some more STD gems.